Well, thank you all for helping my project. Nancy, you were just asking about kind of whether the whole purpose of this thing. So I can give you a little bit of history about it. So last fall, NASA appointed an associate administrator in charge of getting us back to the moon, Doug Laverio. And one of the things that he had was like the little lapel pin with the number of days to the end of 2024 that he was counting down.
Okay.
And he was having a NASA person of the day, which he was calling the hero of the day. And for some reason, during Christmas, I was thinking, wow, what about doing the same thing but with everyday people? And so that
Sure.
began my quest to interview a person of the day until the end of 2024.
Wow, that's a tall order, Nathan.
I know. So far, I haven't missed a day.
That's fantastic.
Yeah, I even took trips to like the UK, and I interviewed people in London and York and Edinburgh,
Wow,
and
that's great.
so it gives you a good reason to talk to people too.
Sure, sure it does.
At least one
Even if you
person a
miss a day,
day.
you could make it up and do two on the next day.
No, I'm afraid the way that my self-discipline works, the moment I
Gotta
miss
be
a day, it's
a catch up.
probably the end of the project. Yeah.
Okay. All
Um,
right. And so, what's the topic?
Oh, the topic. So I wanted to find out what people think about us going back to the moon, and
Oh,
what they think about the future of humanity, and does space exploration fit into that, and do they have a personal interest in going into space? But that's sort of
okay.
the topic. But usually I start out by having people introduce themselves. So
Okay.
maybe y'all could talk a little bit about yourselves.
Sure. Yeah. Gary Stevenson here, and I met Nathan at the Northern National Space Society Houston chapter. And Nathan's been a fantastic proponent, advocate, and volunteer for the NSS. So anything I can do to support you, Nathan, I'm always happy to do that. We met when I was still working at NASA. I worked as the EVA system engineer for United Technologies. So when there was someone going out the door doing a spacewalk, I was the system engineer of record, and I had a whole team backing me up and supporting me on that. I was also the system engineering manager for Houston, which would be all of the human spaceflight type products. So it was a fantastically fun job. It was a very challenging job. I have to say it was quite an exhausting job, but I'm not necessarily unhappy I've left it, but I'd never traded for anything. It was a wonderful experience. So I've always been a huge proponent of human spaceflight, and I was happy to put that 4 years in supporting it directly. Nancy.
Awesome.
Well, I'm Gary's wife. My endeavors are way more terrestrial based. I've been working in oil and gas for Chevron for a number of years. And having worked in Angola and California and Houston and Brazil and 2 times in Kazakhstan, my interest is more earthly. Although I'm fascinated with what you guys do. I just think we have enough problems on Earth. I hope that some of this work we maybe taking ourselves out of the Earth will make us see that we have so many problems we need to address and think bigger and smarter and more globally. So I hope that brings us together.
Yeah, that's a very good question. That same point has come up in a lot of these interviews about the problems we face on Earth, and that's the classic, why are we sending people to the moon whenever we have XYZ problem? But whenever you think about the problems on the Earth, what are the biggest ones that come to mind as being the most threatening?
Boy, I think ignorance right now.
Ignorance of climate change, for instance. And I think just having that vision, that look back from the moon, when we first sent people, I don't know if it was Apollo 8 or exactly what Apollo mission, where they were able to turn the cameras back and get a picture.
This big.
And it's this big and it looks so small and fragile. And I think that zeitgeist really changed the way humanity thinks about our planet.
Yeah, there you are.
Yeah. There we go. Not quite that same picture that you're talking about, but definitely more
of. That's it. There it is in the background. So that's a great example of how spaceflight can change our vision and change the way people think back here on Earth. and I think extremely beneficial ways. Human spaceflight is mind-opening, and that goes for the whole human race, not just the people that happen to be there. We only sent 12 people to the moon, but it's changed forever our view of the Earth.
That's true. So Gary, I didn't realize you were responsible for like every EVA. I knew you worked on spacesuits. So
Right.
that's I wish I had fully understand that more whenever you were here. I would have.
From United Technologies' point of view, from their role, I was the system engineer of record. So from a corporate point of view, that was my role. Of course, there were people at NASA who were responsible for the EVA office. That wasn't my role. But from the system engineering point of view, I was the EVA system engineer of record for the entire 4 years I was there, yes. So it was over 24 EVAs that I was responsible for.
Very stressful.
It was incredibly stressful, incredibly exciting. And I remember once being on vacation and they didn't have the right size spacesuits on the ISS, and they couldn't send both women out. So that's just one of the many things that went wrong while I was there. It's like one of those things that happens when you're on vacation, right? You go away for like 2 weeks and that's what happens.
Oh my goodness. So when did y'all find out that we're planning to go back to the moon in 2024?
Well, it's been a long, gradual process, of course, and the funding has been off and on again. The Constellation project, before I even came back to NASA, was supposed to be in that direction. So I've been supporting the notion for a long time, even before I joined with United Technologies in support of NASA. I did a paper, and you'll remember you actually attended this conference at Mars Society, where I talked about how do we certify a mission to Mars even. This wasn't even beyond the moon. How do you certify a mission to Mars? And so I fell back on all the Constellation material that was certifying this mission for the moon, and incredibly useful material. And so I wrote a paper on certifying human spaceflight to Mars. And that got me interested enough that I really wanted to, at that point, move away from defense space to go to human space. So that was one of the reasons that I switched over. But I guess a more direct answer to your question was, it wasn't until we really got additional funding to do the really rapid mission, where we were talking about the Lunar Gateway. And when they started planning out the Lunar Gateway, even though it may be a stepping stone we don't need for the initial landing on the moon, I knew they were really serious then about lunar missions was the inclusion of that Lunar Gateway, because that's not just going to be for lunar missions and robotic missions to the moon that they can control from the Lunar Gateway. It'll also be a gateway to the rest of the solar system. So for a Mars proponent, I'm also the technical director for Mars Initiative, which is a fundraising arm for building a fund for the first company or organization that lands people on Mars. They'll win this prize money. And so that's another driving impetus for me to support Lunar Gateway and return to the moon. It's practice missions for going to Mars. And this Lunar Gateway will be incredibly useful for a gateway to get to the rest of the solar system, because it's out of the Earth gravity well. And so it's a good jumping off point for the rest of the solar system.
Yeah, I've always wondered about the jumping off point aspect of it. How does like the orbital planes of the Earth, the moon, and Mars interact in terms of what's the difference between them? And does that cause any complications with launching from the moon?
It's a very complex process, because when you're just near a spherical body and then the influence of that spherical body, you can use all the conic sections, right? You can use Euclidean geometry. But as soon as you get away from a single body, you get into multi-body problems. And so you always wind up having to use approximations, and then their solar wind comes into effect. And that's an additional source of force and a source of momentum. So I wrote a paper on this. How I learned about it was I wrote a paper using X-ray navigation for missions to Mars. So you can look for that paper too. I can't remember if it was for STAFE or if it was Mars Society, but presenting that paper taught me a lot about gravitational wells, and getting out of the Earth is the biggest part of it. once you're on the kind of the gravitational saddle point, called Lagrange points, between the moon gravity well and the Earth gravity well, that's kind of the perfect spot to be for launching a low energy mission to Mars. And so that's one of the complexities of it, is how do you navigate that? What's interesting about the Gateway is it's highly elliptical orbit. So if you want to communicate with something on the ground, you wait for that orbit to get close to the moon. And you, for instance, might do some robotic movements or do some remote control of robotic missions that are on the surface, or communicate with people on the surface. But at the other end of the orbit, you're up near that saddle point, up well away from the moon. And that would be your launching off point for an interplanetary type mission.
Yeah, that sounds interesting. Lots of things to look forward to.
Yeah, no, it's going to be a great resource once we get it in place.
I know next year they're launching a CubeSat in that same orbit just to fully understand kind of the dynamics and check it out.
I'm astounded. I'm astounded at the growth of CubeSats. I really think it's the PC of the space industry, because it's a standard where we didn't have standards, right? So it's a set of standards that's incredibly useful. You can build to this form factor almost anything you want. I can remember when I first got Mars Initiative has had a series of interns. When I got my first intern for Mars Initiative, I said, look at using CubeSats for interplanetary missions. What can we use a CubeSat for on Mars? And it wasn't 4 years after he wrote up a series of ideas on that. By the way, he wound up Naval Academy, so I think it served him well to
well, now he's in Monterey.
Yeah, and then he went to Monterey. So I think he's got his official, he's an officer now with the Navy. At any rate, it wasn't 4 years after he wrote that paper that NASA did use CubeSats for remote sensing and remote communication transfer of the reentry process for the last probe that they used to enter Martian atmosphere and land on the surface. And it was basically their only communication source during that landing. So I was astonished that it was less than 4 years from just noodling about the crazy idea of using CubeSats around Mars to having them there and having them do productive work. It's really impressive. I'm encouraged that they're looking at providing GPS services and comm services around the moon using CubeSats. I think they're going to be a fantastic workhorse for the space industry going forward.
Wow, I know a lot of universities are also have students.
Well, that's the other thing, because they're so low cost. Universities can afford them in their budget, and they can be valuable tools for learning and teaching people about spacecraft, because they have all the elements of spacecraft just on a microscopic scale.
I know you have like the standard CubeSat sizes, but
Yeah,
are there like some standard CubeSat buses that provide things like?
Yes, there are. Used to be called Clyde spacecraft there in Great Britain. They make standard frames and standard solar panels and even standard attitude determination and control system, ADCS cards for it. So you can buy them in 1U form factors, which is 10 centimeter by 10 centimeter by 10 centimeter, or you can put 3 of those together for 3U, or even 6 together for 6U. And so those are the standard form factors. Used more often is probably the 3U form factor.
Wow.
If you can have a payload that does real things, remote sensing or comm or GPS.
Oh, that's amazing. Let's see. One of the people who have been coming to North Houston Space Society in the past year, he's been working on a master's in space resources at the Colorado School of Mines. And he was talking about maybe doing a CubeSat project with testing out the artificial gravity using centrifugal rotation. Maybe you could have 2 CubeSats with a tether and put some organism in one and spin it and see how their life spans vary compared to the ones just floating.
Sure. Yeah, that's a perfectly valid test of microgravity and artificial gravity.
Exactly. Yeah. Well, Nancy, when did you hear that we were going back to the moon in 2024?
Well, going to conferences with him, and I remember the first debate was because they want to go to Mars, do we do the moon first and then go to Mars as kind of testing out our equipment?
Zuber, right? Didn't want to stop at the moon. He wanted to go straight to Mars.
And that was, my gosh, that was 10 years ago.
Probably.
Yeah. But what I found really got me excited about it. I mean, I mentioned, I think we need to work on Earth too. And I think this enhances our understanding of Earth. But was, what's his name? At Rice University, we met you there at the lecture by the NASA administrator.
Talking about the current.
Oh, Jim Bridenstine.
Bridenstine. Yeah, his passion was just.
In fact, I have my
fan club. All right.
But, I mean, my gosh,
Yeah,
he's just everybody's cheerleader,
I
isn't he?
hope, regardless of how the next election turns out, that they retain him. He's just fantastic.
Yeah, he was infectious. It was just a really fascinating lecture.
Yeah, he is just perfect for the job.
Yeah.
It's amazing how contentious his appointment was, though. He definitely grew into it.
He did, and it was a really pleasant surprise for those on the other side of the spectrum. That was like, wow, he's really a can-do guy. He's not here to destroy things. He's here to do something constructive, which you can't say for every appointment, but for this appointment, it was really, really a plus. It was a really pleasant surprise.
Yeah. So what do you all think the odds are of him staying there if there is a change in
Oh,
administration?
nobody would replace him.
I think the odds are very high. I'd put him at 85 or 90% odds that he would be asked to stay.
Any ideas on what we could do to push it over to 100 or 99?
Write to your congressman.
I mean, do I need to buy some more shirts? I just let me know what I.
And yeah, be an advocate for sure. You could actually encourage National Space Society to do a position paper on it and send it to the new administration.
They listen.
Yeah, I mean they pull a lot of weight. NSS
Ask
as
Bill
well.
Nye to write it.
Planetary
Okay.
Society, that's another. They could be advocates as well if you get Bill Nye on our side.
Yeah.
Well, Nancy, what do you think about us returning to the moon?
Well, I think it's fascinating. I didn't want to be negative about, my first intro. I don't spend as much time thinking about it as Gary does. But every time I hear about it, it's fascinating, and just the technology and the science, and having worked with Gary, this stuff is really hard. And you see on movies, oh, this looks, interesting. But then when you touch it and you feel it, it's heavy metal, it's physics, it's propulsion. It's really hard to get stuff up there.
And people think a lot about getting it there, but you know, keeping people alive once they're there, that's much harder.
But I'm more fascinated about the psychology of people going up there. How will people behave out, to study the psychology of how human beings will behave in a pod like that.
Space sociology, psychology.
That's going to be interesting.
And also under highly stressed conditions where, it's not, oh, somebody didn't do the dishes. It's, oh my gosh, there's a leak and so we're about to all die.
Yeah, who are we throwing out there to fix it?
Where'd you put the tape? It's like suddenly that's a life and death question.
Who brought the duct tape?
Who brought the duct tape? Yeah. But Nancy, you've mentioned that you felt like one of the biggest threats to humanity here on Earth is ignorance. And the thing about a space colony, it seems like that would be self-correcting, but because you would have to know about your spacecraft. But I was wondering what you saw as a solution to that problem. Like, how do we address that?
I don't know. I'm a little despondent today on where things are going, and it's just I talk to people I used to know, and they were educated. They're my age. They went through progressive education in the 60s, where we were taught critical thinking and questioning things, and then reasoning things through, and believing in truth and facts. And it just seems like today everything's just insane. I mean, I'll see things on the internet and I go, well, that just doesn't add up. I mean, I don't care if they're saying it or not. You can't do this in a certain amount of time, or human beings don't behave that way, or whatever. And then just seeing how people believe what they read without questioning, and there's just so many of us, and I don't know where it's going. I feel a little tad despondent. I don't see things getting better.
Is that one example? Yeah.
Yeah, climate change is the perfect example, because that takes so much of humanity to coalesce and move toward one belief and one vision. Well, maybe not one vision, but at least one belief, and giving up things. I mean, I like my house. I like my big house. I'm not convinced we can't all live better with less energy or better resources management, but it just takes a lot of human will. And I just see us vibrating in all directions. I don't know how that will coalesce. I don't see how it can happen. I'm not in a very good mood today.
I think the lessons from biosphere are powerful here, because it's living in a closed system. That's what we're doing.
Yep, that was 8 people.
Biosphere 2 is 8 people, but Biosphere 1 is all of us.
Oh, yes.
Right? So if you play the lessons back from Biosphere 2 and look at Biosphere 1, it's a closed system. We all have to figure this out together. And I think human spaceflight helps with that vision, because like your picture there, you can see it behind them. Yes, they're living together in one tiny commune on lunar soil, but we're all living together right behind them on that little planet. Yeah. So I think that sort of thinking helps develop and helps coalesce humankind.
I don't know. See. We're going to have to rethink a lot of things. Nationalism, for one.
Well, I mean, all the nations are living together on the same planet. So nationalism isn't going to fix that. Yeah.
Yeah. I mean, these are basic things we're going to have to really look at.
I was wondering, I mean, we talk about how like the internet helps give people access to information, but
that's true.
And you talked about how people just read stuff uncritically and just accept their answers. And thinking over the course of my life, I remember having to go to the library and look up stuff in the card catalog, and finding something that would give you an answer to your question wasn't really possible. Like you couldn't just type in
button.
Yeah, you couldn't type in something into Google and get an answer back. You had to, I mean, even if there was an answer someplace, it required critical thinking to actually find the path to get to it.
You got a really good point, Nathan. Yeah.
We had an experience, the Jetsons and James Cameron. I'm not, I don't just trusting what Google throws at you. It's scrubbed now, and people know how to manage and get stuff in front of you.
Reputation defender.
Yeah. So an example was, you've got to watch it, The Jetsons, the 1990 movie.
Mm-hmm.
And it is so colorful. I just came across it on Amazon, I think.
It was finally free on Amazon Prime.
Yeah, it's on Amazon Prime. And it's eye candy. But we start watching the movie, and George Jetson gets sent up to a mining asteroid that Mr. Spacely's Sprockets owns. And we start watching the evolution, and it is exactly the script of Avatar. It is the script. Judy falls in love with one of the blue people, and they're destroying their habitat. Everything is the same. Habitat, yeah. 4 years later, James Cameron writes Avatar. So I go, okay, somebody's been sued for this. I've got to find out. I looked and looked and looked, and no one had, only one guy in Cincinnati, a newspaper,
Cleveland.
And it was a PDF thing, not a word search. It was a PDF article.
Cleveland movie critic, yeah, had something up still.
And so you couldn't scrub it.
Right.
And I looked and looked and looked. Nobody had talked about comparison.
He's the only one that was like
plagiarism.
Yeah, he was astounded, just like we were. He's the only other one that noticed it.
But it's not on the internet. Now,
in that one spot, that was it.
And it was a PDF, and you can't word search the picture.
You can. That's a lot harder. It's a word search a PDF. Yeah.
So I don't know. I'm going, what is on the internet now that I can't find things? I don't know.
So you can't put too much trust in the internet.
Well, I mean, talking about the kind of taking away information and sort of the not the Brave New World, 1984, I guess is the one where it's the whole
George Orwell. Yeah.
George Orwell, yeah. So you all remember the incident with Kindles. Apparently, a copy of 1984 got out there and was being distributed freely. And in order to address this issue, they actually deleted the copy from everybody's Kindle. It's like completely.
I'm sure that's a public domain book. I mean, he's been dead forever. I can't believe that would be copyrighted.
That's weird.
Yeah. Anyway.
Well, bringing that up, Gary was asking Amazon at one time, when he dies, who owns these movies he's bought online?
Yeah, because you
don't own them.
You purchase them for life, but when your life is over, you don't get to bequeath them to anyone.
Wow.
It happens to intellectual property that you've purchased and have access to. It's really just a license to watch it while you're alive. It's not really your property.
Yeah, you had to start a family corporation, create the Amazon account in the family corporation, and pass it down to your children.
Yeah, yeah. Well, so I'm sure some lawyer family will be clever enough to do that. So they'll challenge Amazon on it.
Yeah.
Seems to have not been addressed.
No.
Yeah.
Whereas if you own a DVD, you can pass it on to your kids forever.
Yeah, I own a lot of DVDs. I just don't have a DVD player. So
there's a lot of people like that now.
Yeah. So, do you remember back in the 1990s how at the beginning of 1990, almost nobody knew what email address was. We used BBSs and dial-up services if you used anything.
I had a Prodigy computer.
Yeah,
yes.
Prodigy, CompuServe.
It was like 89, 90 when we first met, and she had email and Prodigy service way before I did.
But even Prodigy service, I mean, you could email other people on Prodigy, but you really could. I mean, a lot of people were on these dial-up BBSs.
Well, it was dial-up. It was ding, ding, ding. It sounded like a modem dial-up when you turned it on. Yeah. I thought it was pretty cool. It was color.
It was very cool. I actually used it to research scud dimensions before Gulf War I.
Okay. That is neat. But by like 2000, pretty much everybody had email. Everybody knew what the internet was. You could buy things online and search things. I mean, like the 1990s was a hugely transformative period
Absolutely.
for the internet, such that you could describe everyday experiences to somebody that were possible in 2000, somebody living in 1990, and they would have no idea what you're talking about.
Yeah.
And I feel like the 2020s are going to be that way for space exploration, between what SpaceX is doing with their Starship and, Blue Origin's been hiring like crazy. I was just talking to a person for this program at Blue Origin yesterday, and just hearing her enthusiasm and all the stuff that they're doing. I mean, I just think it's just a matter of time before we're all really amazed at what they've been doing behind the scenes.
I agree. I mean, we're talking about how expansive, travel can be. Space travel doubly so. If you really want to open up your vistas, you maybe want to do some space travel for tourism. So I can easily see how 20, 40 years from now, this will be a big tourist destination.
But
something.
But if we just think 10 years from now, what do you think will be commonplace in 2030 that was unimaginable today?
Oh boy, this is for the archives.
Yeah. I think new launch techniques. I really think chemical rockets are limiting right now from a cost point of view. They're a little bit of a dead end technology. I see for unmanned payloads, electromagnetic railguns. That's one of our holdings actually. If you have Space Fund 1, and then Space Fund 2 is now coming up right behind it. This is a venture capital pot of money. Yeah.
Actually, I don't.
Megan, right?
Is it Megan? Megan Crawford.
Megan Crawford.
Yes.
Yeah, I think she pitched it once.
She did.
Investors in Space Fund 1. And one of their holdings is electromagnetic railgun that will be used for launch. So that's going to be driving the cost way down for unmanned payloads. I'm not sure that I would want to take that ride. It's probably 100 Gs. But for human spaceflight, single stage to orbit, I really think magnetohydrodynamics is a powerful technology for like the 2030 timeframe. And so people are scrambling now for patent positions on that very subject. And right now it takes too much electrical energy to run it effectively, but as batteries get better and as we find other ways to store electrical energy, like SFIS, this is going to be a technology that could potentially launch people right off the surface of the Earth, like a Millennial Falcon style. So
And two things, energy and transportation, terrestrial and space,
yeah,
are going to
yeah.
be.
So energy storage is changing, propulsion is changing. And I do see that as enablers going out way into the future. I've spent a lot of my time looking at gravitomagnetic propulsion, which is essentially field propulsion. So this is another potential game changer, because you don't have to go at Mach 30, to leave the Earth. You can go at 60 miles an hour straight up if you have field propulsion. And you don't even need like shielding or anything for that, right? If you're going that slow. With field propulsion, if you just negate gravity and make a gravitational field around your craft, then it's literally just floating off the Earth. And that would be an enormous improvement and game changer in terms of cost once that technology is developed. So there's a lot, and that's probably more like 30 years away, right? That'll take a lot. That's a bigger get than MHD. But those technologies are valid technologies that aren't developed yet. The physics works, but the technology isn't there. So if the physics works, the technology will sooner or later get there. I really believe that.
So in terms of the floating off Earth and the gravitational technology,
Yeah.
who's working on that?
I published a paper at Marcel Grossman in 2018. This is a biannual conference of general relativists that described one possible way to do it. Using a toroid, you can have the motion of masses summed together in a way that creates a Lenz-Thirring effect that creates a scalar field, a scalar gravitational field. Now, right now with the technology we have, it's extremely weak. It's to the point where you can barely measure it. So I described a device about 10 meters across that will create a field in the middle that's barely measurable. It might be like nano-Gs or hundreds of nano-Gs or even a micro-G. If you can get to 100 nano-Gs or a micro-G, you can measure the effect. Then it's just a matter of improving the technology. And we're getting improvements in superconductors, and we're getting improvements with current densities in nanowires that are now so high that we can look at using it as a real propulsion technique. Maybe for now only in space, but someday on Earth too, where we could start talking about 1G type numbers.
Yeah, I saw the cover of Nature for this month, or I guess this week, said room temperature superconductors are apparently a thing. So
Yes.
I sent you that article, I think.
Yeah, I actually posted
it was on Twitter.
I posted to my Facebook back in February when they first ran the experiment. The problem is it's like 35 million PSI. So, we don't live at 35 million PSI. So it's room temperature, but it's not room pressure. We need something that works at room temperature and room pressure.
it's interesting that
superconductors, and we're getting closer. It's to the point now where it's like 200 Kelvin. You can start talking about electrical refrigerators, like nitrogen is 77. But we can talk about mechanical refrigerators keeping it cold at 200 Kelvin. And then you can talk about a real battery. If you can store magnetically in these superconducting magnetic energy storage, SMES devices, if you can run them at 200 Kelvin, that's a really valid thing. Keep them in a refrigerator. That now you can store massive amounts of energy in these devices. Thousands or tens or hundreds of thousands times more compact than batteries.
I'm afraid to hear the answer to this question, but what do you think civilization will be like 500 years from now?
Unimaginable, I'm sure, for us. Yeah. There's some interesting trends. You can look at the space-time trend, the physics trend, where in the physical universe, we're going to be able to expand greatly as a civilization, especially if we get warp drive figured out. But there's also the cyber trend, where do we need physical bodies even? I mean, already the gamers spend a lot of time on the internet. Artificial intelligence is advancing all the time. So do we need physical bodies? I mean, I don't know the answer to that. I know my DNA can be represented in a computer right now. I think the last time I was at an NSS annual conference, I forget the president's name, but he talked about a device that where we don't send ourselves to another planet, we send a 3D printer of our DNA to the other planet, and it prints our DNA. And then we start up a civilization with basically a DNA printer. So I could easily envision 500 years from now, that kind of thing happening.
Yeah, it really calls into question, who are we and what does it mean to be?
Yeah, what does the human race mean at that point? Or are we the human race, or are we something else?
Wow. Nancy, what are your thoughts?
She doesn't want to go there. We've had this talk. She's like, I'm not sure I want to be alive then.
No.
I was asking Rachel, the executive director for Space for Humanity, and she was saying that she kind of imagined us being transhuman, like maybe we would just be like a wave of light.
Yeah.
And it occurred to me that that panspermia theory of where life came from. What if that's already happened? We talk about the spirit,
and we're the products of that. Yes.
Yeah, I mean,
we're made in God's image because we were panspermia, seeded the planet Earth. Who knows?
And then we became like these receptors at some point over the course from inception to later of like consciousness that gets beamed from like another civilization or what have you. So kind of
another interest of mine is quantum entanglement, because it doesn't need the boundaries. It doesn't honor the boundaries of space distance. You can, if it's quantum entangled, it's operating on the same quantum state. So the quantum state of anything that's quantum entangled switches at the same exact time. It doesn't follow the speed of light. So you can have quantum entanglement radio between two planets that it is the same quantum value. So if you can manipulate one and you don't lose coherence on the other, you're basically communicating between two different places that may be not just two planets away, but two galaxies away. And so who's to say what kind of quantum entanglement may have already touched us on this planet?
It would definitely explain phenomena like serendipity and things like that.
Mm-hmm.
What's the easiest way to see a demonstration of quantum entanglement?
I gave another paper on this, and you sat through this horribly boring paper I gave at a Bill conference, I think in 2014. 2014 was a big breakthrough year for quantum entanglement. There were 3 big experiments. The one was the Canary Islands experiment, where they quantum entangled 2 sets of particles, one on one island and one a couple hundred miles on the other island. And when they flipped the state of one, they measured when the state flipped on the other one, and it flipped at the exact same time, instantaneously. And they had measured, they could tell the difference between speed of light difference versus instantaneous, and it was instantaneous. So that was a huge breakthrough. I think Herbert Smithite is another one from that year, where they measured quantum entanglement states in a solid crystal. And so when they would change the state in one piece of the crystal, the entire crystal changed in this Herbert Smithite. So I can send you that paper as well, but it's readily available online.
But what would it take to replicate that experiment?
A big lab. MIT could probably do it.
Well, if it was safe and affordable, would y'all have any interest in going into space?
I'll let you go first.
I'm not sure. It's like you would ask someone in 1910, well, if it was safe and affordable, would you be willing to fly in an airplane? Well, look how we've adapted, right? So I can't project out that far. I'm not going to be the first one, the second one, or when it's routine and I've adapted, we will, of course.
This is going to sound funny coming from someone who worked on spacesuits, but I'm claustrophobic.
Yeah.
So I'm going to go into space when you can go first class and have a lot of room. I need lots of room. I need to be able to stretch out. Yeah, of course. So when you can go first class, that's when you sign me up. I want a big suite with a big window. Just like a cruise ship, just like, what was the movie with Bruce Willis?
Oh, yeah. The Fifth Element.
Fifth Element, where they go on a cruise in space. That's how I want to go.
Didn't that look like fun?
When there's a cruise ship, I wore my Seaborn for this interview.
Oh, cool.
Seaborn offers a cruise to Mars. That is when you can sign me up.
Well, have you all heard of the space perspective?
No.
It's talking about the Biosphere 2 earlier. So two of those people, Jane Poynter and Tabor McAuliffe, I think is his name. They were one of the 8 people in Biosphere 2. They started several space companies, and now they're starting another one called the Space Perspective, which aims to build. Yeah,
it's the balloon, right?
Yeah, the balloon. And they'll be launching in Florida. It'd hold 9 people in this big capsule. It'd have a bar in it. It'd have seats. You have great view. Goes up to 100,000 feet. Lands in the water. They retrieve you. It takes about 4 or 5 hours.
I'm going to answer your question with a question. Have you heard of the Hindenburg?
I have. And
It's
they are
another
using hydrogen.
balloon.
Oh, come now. We better got better storage.
But you got to have an oxidizer and you got to have a spark, a heat source. We're going to keep both of those things away from it.
When she announced this to me, we had this talk, and I said, as long as you have good charge abatement, you might get me interested. But you better show me your charge abatement plan, because that was the source of the spark for the Hindenburg, static electricity.
But there are going to be hydrogen fuel cells, space or airplanes in the very near future. They're piloting them and testing them. So we were just talking about this. Hydrogen storage has come a long way.
It's come a long way. It's
and I think last I heard it was like ceramic sponges.
And so it's not an inflammable wrapper anymore.
I tried to hold hydrogen at the refinery and on the pipelines underneath LA County. And it's not easy to keep hydrogen in its place.
Slippery stuff.
Yeah, it oozes out everywhere. But it's going to happen.
Would you go on that?
Oh, I know my train of thought. That Tabor fellow is really brilliant. If you have caught his documentary about the domes, a Biosphere 2, it's a fabulous documentary. And they were incredible. They were hippies in Berkeley and figured out how to make a boat with a ship without the internet, without any engineering degrees, without any construction.
They were pretty wild. Have you seen the documentary?
I haven't. I need to. But the Hercules, I think, is the name of the boat. It's a cement bottom boat, and he lived on it for 2 years. But it's still going around, and people still can go on it.
It's amazing.
Well, we are going to make a trip down to the Biosphere 2 one day.
For me, it's a pilgrimage.
Yeah.
Because it's the first attempt, really at a self-sustained closed system.
Yeah, it was for us too. I've always wanted to go, and we finally went. I think about 3 years ago. So it was
really
worthwhile. Yeah, I loved it. I just was kind of sad that they had sort of those social political issues that kind of kept them from continuing, because it would have been such a neat legacy for it.
And so much of their data was lost. They collected.
Yeah, that was the heartbreaking thing for me when I talked to Greg Stanley about this, who's clearly an expert on it, is just that they didn't hang on to the data.
Oh, really? I guess they didn't have. Maybe I should turn off the video for the virtual background. I guess they couldn't get 1 terabyte micro SD cards.
It was so easy to save. I think there was a lot of controversy about they had to bring in oxygen, but it's still valid data. And the reason for that, they didn't discover until later, was the concrete was curing still. So it was sucking up a lot of the O2. And so I think that's a huge breakthrough to say, don't inhabit this space while the concrete's still curing. That's a game changer. And we could have killed people on the moon had they not discovered that, but by that same O2 absorption problem. So I think it's a shame that they let their critics, have them push them away from their data.
Yeah, exactly.
Experiment, as long as you keep the data.
But I was really glad to go there and see it. It's definitely worthwhile.
I definitely still want to go.
So one thing I should mention, talking about this micro SD card is not just sitting on my desk randomly. I'm planning to take all these videos and put them on the micro SD card, and I'm sending it as part of the Astrobotic mission to the moon this coming Sunday, summer. So
Okay,
next,
okay. I hope it'll be shielded well enough that the data will last.
Unfortunately, you can't hope in that, but I'm hoping on magical futuristic technologies is able to reconstruct it.
Well done.
What did humans look like? Yeah.
What were they concerned about?
Exactly. Exactly. Well, I really appreciate y'all's time. Is there anything that y'all wanted to say that we didn't talk about?
Very ambitious and
It
imaginative
is.
of you
Yeah,
to do this.
really fantastic, Nathan. I'd make a backup before you send the originals to the moon.
Yeah, no, definitely. I mean, I post them on my website, countdowntothemoon.org.
Okay.
So
We'll look through them. It'd be interesting to see what everyone else said.
excellent.
Some interesting discussions.
I have, yes, they range anywhere from 55 seconds to 3.5 hours.
Oh, wow. I think an hour is plenty for us. I don't have that many interesting things to say.
Well, that's one of the challenges with the project is talking to random strangers in a coffee shop. It's definitely a lot more constrained conversation in terms of time than setting it up on Zoom ahead of time. It kind of,
Right.
the average is much higher since March.
Well, yeah, because we're all locked down now. So Zoom is how we do things.
Exactly. Exactly.
All right, Nathan. Well, best of luck on your project.
Yeah, thank y'all so much. And if y'all know anybody else that'd be willing to talk to me, especially non-space people.
We'll mention it in social gatherings. We have if everyone gets tested in time, we have a Thanksgiving gathering here with family. And so we'll hit them up.
That'd be awesome. Yep, they got plenty of time. I got 4 more years to go, so.
Okay. Good deal. All right, take care.
Okay, bye-bye.